All right, let's dive in. You've heard the term AI agent everywhere, right? It's this big promise of fully autonomous systems that can basically solve anything you throw at them. But what's actually going on behind the curtain? Well, today we're going to cut through all that hype, using some really practical insights from the engineering team at Anthropic to see how the most effective AI systems are really built.
And this quote from Anthropic, it really just nails it. Success here isn't about hunting down the most complicated, all-in-one framework you can find. It's actually about using simple, easy-to-understand building blocks that you can snap together like Legos. The big takeaway is that simplicity almost always beats complexity.
So here's our game plan for this explainer. First, we'll tackle that agent hype head-on. Then we'll draw a super important line between what we'll call workflows and true agents. After that, the fun part. We'll build a practical toolkit of patterns. Then we'll talk about when to go fully autonomous, and we'll wrap it all up with 3 essential rules for anyone building these things. Okay, so with all this noise around AI agents, what's Anthropic's #1 piece of advice? It's simple. Find the simplest possible solution that works. Seriously, you should only add more complexity when you can absolutely prove you need it, which, might mean you don't end up building a complex agentic system at all.
And a huge piece of this start simple idea is dodging what they call the framework trap. These frameworks can look like a great shortcut, but all those layers of abstraction can actually hide what's going on underneath. It makes debugging a nightmare and just tempts you to build something way too complicated. The core advice? Just start with direct API calls to the LLM. You'd be amazed how many powerful patterns you can build with just a few lines of your own code.
Okay, this next part is super important. It's a key architectural idea that will change how you think about these systems. See, not all agentic systems are created equal. Anthropic draws a really clear line between 2 main types, workflows and true agents. And honestly, getting this distinction right is the key to building anything effective.
And this slide just lays it out perfectly. On the left, you've got workflows. These are directed by code that you write. They follow a predictable, preset path, which is exactly what you want for well-defined tasks where you already know the steps. But on the right, you have a true agent. This thing is orchestrated by the LLM itself. It's dynamic, it's flexible, and it figures out its own path as it goes, perfect for those messy, open-ended problems.
All right, this is where we get our hands dirty. Let's build a toolkit. We're about to walk through 5 really powerful, composable patterns that you can mix and match. Think of these as the fundamental building blocks for creating some seriously robust and effective AI systems.
But first things first, before we get to the patterns, we need to understand the bedrock that they're all built on, the augmented LLM. This is not your standard off-the-shelf language model. No, this is an LLM with superpowers. It's been given a set of tools to interact with the outside world, a retrieval system so it can look up information, and a memory to keep track of the conversation. Every single pattern we're about to see stands on the shoulders of this enhanced foundation.
Our first pattern, and probably the simplest, is prompt caning. The idea is brilliant. Just break a big task into a sequence of smaller, more manageable steps. For example, instead of just telling an LLM to write a report, you'd first have it generate an outline. Then, and this is the key, your own code can check that outline to make sure it's good. If it passes your checks, then you make a second call to the LLM to write the full document based on that approved outline. You trade a tiny bit of latency for a massive boost in quality and control.
Next up is routing. And honestly, the best way to think about this is like an intelligent switchboard. When a query comes in, the first LLM call doesn't even try to answer it. Its only job is to classify the request. Is this a sales question? Is it a technical support issue? Based on that label, it then routes the query to a completely different, highly specialized prompt or tool that's been fine-tuned for that one specific job. This is how you avoid having one giant, messy prompt that tries to do everything, but does it all poorly.
Pattern number 3, parallelization, actually comes in 2 different flavors. The first is sectioning, and it's all about speed. You break a task into independent pieces and run them all at the same time. So one LLM could be working on the user's query, while another one is screening it for safety, simultaneously. The second flavor is voting, and this is all about quality and confidence. Here, you run the exact same task multiple times, maybe with slightly different instructions, to get a diverse set of answers. It's like having 3 different experts review some code. You're way more likely to catch any problems.
Now, building on that idea of multiple AIs working together, we get the orchestrator-worker pattern. But this one's way more dynamic. You have a central orchestrator LLM that takes a look at a really complex problem and basically invents the subtasks on the fly. It then farms out those new tasks to several worker LLMs. Once they're done, the orchestrator gathers up all the results and puts them together into a final answer. The magic here is that the subtasks aren't predefined. They're created in real time by the orchestrator.
Our final pattern is the evaluator optimizer, and it is incredibly powerful because it basically mimics how we as humans work. It creates this iterative feedback loop. One LLM generates a response, and then a second evaluator LLM critiques that response against a set of rules. That feedback then gets sent back to the first LLM, which refines its answer. This loop just keeps going: generate, critique, refine, until the output is good enough. It's exactly like writing a document. You draft it, you review it, you revise it, and you repeat.
Okay, so we've got our toolbox full of these powerful patterns. The big question now is, when do we actually connect them all together and let the LLM take the wheel? When do we build a truly autonomous agent? This is the moment we shift from those structured workflows to dynamic, real-time problem solving.
So what really defines an autonomous agent? Well, it's when the LLM is in the driver's seat, period. It dynamically plans its own steps, it decides for itself which tools to use, and, most importantly, it operates in a feedback loop with its environment. It takes an action, sees what happens, like did the code it wrote actually run, and then uses that real-world feedback to figure out what to do next.
So, you should really only deploy a true agent for those big, open-ended problems where you couldn't possibly predict all the steps ahead of time. But, and this is a big but, this power comes with some serious warnings. Agents cost more and they're slower. And because they're in a loop, a tiny error at the beginning can snowball into a massive failure later on. The absolute, non-negotiable rule here is to always test these things thoroughly in a safe, sandboxed environment.
All right, we've covered the what and the how, all the technical patterns. Now let's zoom out and talk about the philosophy. Anthropic lays out 3 core principles that should really guide how you approach building these systems if you want them to be successful in the long run.
And here they are. Number 1, simplicity. We've come full circle on that one. It's the most important rule. Number 2, transparency. You should let the user see the agent's plan as it's forming. This builds trust and makes debugging so much easier. And number 3, craftsmanship, specifically with the Agent-Computer Interface, or ACI. Now that sounds fancy, but all it means is that the tools you give the agent need to be incredibly well-documented, reliable, and easy for the AI to understand. If your tools are confusing or flaky, the entire system is going to fall apart.
And that really brings us right back to the main idea. Success in this field isn't about building the most complex, futuristic system you can imagine. It's about building the right system for the job. So the question I want to leave you with is this. Looking at the problem you're trying to solve right now, what's the simplest, most effective pattern from this toolkit that you could apply today?